Alright, so here is the curve sketching problem that I promised to do. The function is y equals 2x over x squared minus 1, and we are asked to sketch a graph of the curve, a detailed sketch. So I'm just going to work through it all. First of all, before I start looking at anything, I'm just going to go from the original function. And so when I look at that, things that I can figure out easily as well, I know, and I'm going to do all my work on this left side here, and then I'm just going to keep my notes on the other side. It's y equals 2x over, and I can factor that bottom. I just recognize that I can factor it nice and quick. So if I did that, it would look like this. Now the only reason I'm going to factor is because I want to see where the zeros of the denominator are. And so really quickly, just from y, the things that I can get is I can see that when x equals 0, y equals 0. My 0 is just easy to find because if I set my numerator equal to 0, I'm going to get a 0. That's not a necessary point. It's just something I saw quickly. I also know that when x, we have asymptotes. We have vertical asymptotes when x equals 1 and when x equals negative 1. And I notice that because the 0 is my denominator and those aren't repeated zeros in the numerator. So again, just things that I noticed quickly. You would have eventually noticed those anyway. I'm just picking them up right now. Other things that I notice, well, if I look at my original function, in the original form, I can see my end behavior. So I know my limit as x goes to infinity. When I look, my denominator is really growing drastically in size compared to my numerator. So my limit would be equal to 0. And that's actually true from both sides. The only thing that I notice that's different is that if I'm going to positive infinity, both my numerator and denominator are positive. Whereas if I'm going to negative infinity, I forgot my negative infinity mark, huh? There we go. If I'm going to negative infinity, I notice that my numerator is becoming negative and my denominator is going to be positive. So I'm going to be coming kind of from the negative side. Whereas up here, I'm going to be coming from the positive side. So those little orange marks are just notes for me. Now, there's not a ton else that I can see instantly, and I'm not going to spend too much time doing work with the original function. If I don't need to, what's the point, So I'm going to go ahead and get rid of my factored form, because if I'm going to figure anything else out, I don't really want to work with that form. It's just more complicated looking. So now I'm going to go ahead and switch, and I'm going to figure out things that I can from my derivative, which means I need to take it first. When I look at this, there's no easy way to simplify it. I definitely thought about that first. So I'm going to use the quotient rule. So, my low multiplied by my high, the derivative of my high, low d high. So multiplied by 2 minus high multiplied by the derivative of my low, which is 2x, all over x squared minus 1 squared. Now what I've noticed is some of you will actually square out your denominator. I don't want to do that. And the reason, one, if I'm going to simplify this, it's going to come from me factoring out something like the denominator. I do want to keep in mind that that has x plus 1 and x minus 1 in it. Maybe that would lead to something. But the other reason is just because when you look at that denominator, that's a nice version to calculate. If I shove a number in there for x, if I substitute for x, it's quick to evaluate. Or if I expand it, it's going to be slower. Plus, it's going to have taken me time to expand it. The other reason, it's easier to evaluate positive, negative in this form than it is if it was expanded. basically the expanded version doesn't give me any benefits whatsoever, so what's the point? I will go ahead and simplify the top because that looks just disheveled. So I have 2x squared minus 2 subtract 4x squared. Ooh, this problem's going to make a liar out of me. I can see it. So, because then I get y prime equals negative 2x squared minus 2 over x squared minus 1 squared. Let me see where it's making a liar out of me. And then I could factor a negative 2 out of the top because it's a common factor. And I get x squared plus 1. No, I guess it didn't make a liar out of me. I don't see a way that I could really do anything differently. Yeah. So, you know, honestly, at this point, I'm like, oh, I wish that top was an x squared minus 1. I wonder, did I screw up? You know, that's an instant thought for me. So I look back at my work, and, you know, I'm looking for my mistakes, and I don't see any. Maybe I'm missing it, but hey, I don't see any. So now keep in mind that at this point, I have the derivative, so I can figure things out. What can I figure out? Well, I can figure out my critical values. So I'm really wondering, where is my derivative equal to 0 or undefined? Which means I'm really looking for, you know, my CVs, right? Where is the numerator equal to 0? Because that would make the whole thing equal to 0. And x squared plus 1 is never gonna be 0. Got it. All right. Ugh. That doesn't work. All right. What about the denominator? Well, and this again is why I kept the form. So if I want my denominator to be 0, think about it. That's really going to make my whole derivative function up here undefined, right? So if I want my denominator to be 0, well, I've got that familiar group there. So, you know, I already solved the zeros for that. So I already know, like, the zeros of this are 1 and negative 1. So that's interesting. So I know for y prime over here, I know we could have changes in slope at 1 and negative 1. Which, if I'm thinking, those are where my asymptotes are. So that makes sense that I could potentially have changes there. But I don't have to worry about finding y values of those because they're vertical asymptotes. So there's that. I'm trying to think other things I could use my derivative for. Zeros of the derivative, undefineds of the derivative. Those are spots where my my slope can change. So I'm going to erase my work up here. And then I'm going to make my funky little sign chart. And I'm looking at x values, and I'm looking at y prime values. And I'm looking at negative 1. Whoop! Wrong side. My bad. Looking at negative 1, and I'm looking at positive 1, right? And then, so if I look at y prime, and again, this is why I kept it in the form it is, if I try something like, I don't know, x equals negative 2, just to keep it simple, right? I guess I could actually use something huge. Maybe that's going to make it even easier. You know, like negative 100. If I plug that into the numerator, well, it's going to get squared, which is going to become positive. Plus 1 become positive. And then I'm going to have multiplied by negative 2. So I'm going to get negative. And then in the denominator, if I plug it in, it's going to get squared minus 100, or sorry, minus 1. So I'm going to have a really big positive, but then it's going to get squared, so it's going to stay positive. So I'm going to have a negative value right there. All right, so that's out of the way. Next, what if I look at 0? 0 is awesome. If I plug in 0 in the numerator, negative, denominator, positive. In fact, my denominator is always going to be positive because it gets squared, right? And my numerator is always going to be negative because I have something positive inside of there. You know, because of the square and plus 1 multiplied by a negative 2. So I know right now I don't even need a test anymore. I've noticed this pattern. So what's the point, right? So my slope is always negative. My slope for y, sorry, I need to be clear, right? Well, that's weird. All right. So let's keep going. I'm going to write my derivative up here. Ooh, sorry. Program malfunction. You probably didn't see that, though. And it's over x squared minus 1 squared. Now, I know that you're thinking, oh, man, we still have to go to the second derivative to look at concavity. That looks like it's going to be a beast. And maybe it will. But we're going to handle it anyway. So, y double prime. And again, I'm going to use the quotient rule. So I'm going to go low x squared minus 1. Again, I'm not multiplying that by out. I'm hoping this is going to help me. D high. Ooh. So I know that negative 2 is going to stay as a multiplier. Yeah, it's starting to look sloppy there, so maybe I'll just use a grouping symbol. So negative 2. And then times the derivative, you know, x squared plus 1, which is just 2x. So I guess this is going to become a 4x, right? Negative 4x. Cool. Minus. Sorry, I'm thinking back to my derivative and making sure that I subtracted there. Really hoping that I did. Low D high minus high D low. Yeah, I did. Good. Whoo! All right. Subtract high. So we have negative 2 x squared plus 1. I know it looks sloppy. I'm sorry. Multiplied by the derivative of the denominator 2 multiplied by x squared minus 1. Wow, this is a nightmare. Multiplied by 2x because I'm using the chain rule. Horrible mess. And this is now going to be squared, so it's going to be raised to the 4th power. Wow. Wow, right? Right. Now, I could go ahead and multiply all of this out, but that would be a mistake, at least right now. What I'm going to look for are commonalities, and I'm just going to try to take care of some of the things. Sorry, that's the dog. Right now on their own. You know, I don't like the way I wrote that. So I'm just going to clean up the form, and then maybe I'll notice some commonalities, right? I'm seeing some already, but I want you guys to see them too. So this is negative, and there's another negative in there. So I'm actually going to have plus here. And then I have a 2, I have another 2, and I have another 2. So I really get, so that 2, 2, and 2, so I'm going to get an 8. So, and then I notice I'm picking up just a normal x right there at the end. And then I have my x squared plus 1 factor, and I have my x squared minus 1 factor. Now, maybe this doesn't look a ton simpler to you, but it does to me some. Plus, things that I notice, well, everything has an x squared minus 1 factor. See, I've got one of them there, I've got 2 of them there, so I can get rid of 1, and I've got 4 of them there, so I have 3 left in the denominator. So that cleans things up pretty drastically. This also means that I can start to simplify my numerator. So I'd get negative 4x cubed plus 4x plus 8x cubed plus 8x. And over my numerator again. It's only the third power now, so. And that's not so bad, because again, I'm thinking I'm going to find zeros and undefined points, and so who really cares about my denominator, right? So then on my top, if I combine like terms, I'm going to have 4x cubed, which isn't so bad, and then I'm going to have plus 12x, which is starting to look really, really nice, I mean, who really cares that it was a sloppy mess in the beginning? I don't need to multiply everything out. If I make some smart choices of simplifying before I ever multiply out, it's going to look way better. That smart choice was not to worry about my groups in the beginning. Leave the groups alone, and as I work, I can try to cancel out a full group so I don't ever have to multiply it. And then once I have as little groups as possible, then if I want, I can multiply it out. So, instantly I know I'm going to be looking for zeros and undefined points. So zeros is the numerator and denominator. So I'm going to go ahead and factor this. So 4x squared multiplied by x plus, can't pull out a square, can I? Silly painter. X squared plus 3 all over x squared minus 1. Now, obviously I've run out of room to work. You guys wouldn't, because you have a ton of space, but I have. So what I'm going to do is I'm going to erase all of this beautiful work you see before you there. Bigger erasing tool. Lots to erase there. All right, so I've got a munchkin sitting next to me now, so if you hear like a sound, it's just my son. Anyway, so I'm looking for when this is 0, because I'm thinking I'd like to find my IPs, or undefined, where the concavity could change. And so when I'm looking, my zeros is going to be are going to occur when my top, if I use proper English, is going to be 0, which x squared plus 3 is never going to be 0. Something squared plus 3 will never make 0. So the only thing that could be 0 is that first term. That's why I like that factored form. So it's going to be when x equals 0. And then I'm looking for when my second derivative is undefined, which is really occurring when my denominator is 0. Wow, talk about repeated reasoning. Which we've already looked at that. This is why I keep it in that factored form. It's why I'm not multiplying it out, because then I can see that that's going to occur when x is 1 or negative 1. Surprise, my concavity can change when I have an asymptote. Yeah, got it. All right, so if we then erase that work and I make my handy dandy little sign chart for this one, I guess I didn't need to erase it, did I? I could have just came over here. The spots of interest are negative 1, 0, and positive 1. And I want to know about my second derivative because I'm looking at concavity. And so if I think about that, if I plug in something hugely negative, like negative 1,000. I guess that's not even that huge, but I'm going to have a negative here multiplied by a positive there. And then I'm going to have a positive, because of the square, cubed. Well, a positive squared, huge positive minus 1 cubed. So I'm going to have a positive in the denominator. So I know that that's going to be negative overall. All right. Then, if I change my test point to something in between negative 1 and 0, And this is going to become significant. So if I test it to something like, negative 0.1, right? I'm going to get a negative again right there. I'm going to get a positive again right there because something squared plus 3. But here, I get some positive number, but minus 1. That minus 1 is going to overtake the size of the positive that's coming from there. And so it's going to make it negative overall. Because then a negative cubed is negative. So I have a negative over a negative, which is going to be a positive. So I have a positive second derivative there. Now, similarly, if I think about it, if I just erase that test, does anything change? Well, yeah, that's going to become a positive, right? And I have a positive number. And then in my denominator, I'm still going to get a negative inside of there, cubed. So it's still going to be a negative. But that means that overall, I have a negative curvature there. And then finally, if I test something hugely positive, something like 1,000,000, well, this is going to be positive, this is going to be positive, and this is going to be positive. So I'm going to have a positive concavity at the end. All right, we're almost there. I know it seems like a lot. Let's see. Let's figure out y values really quick if any points we need to. Important spots. 0 and x equals 0. Already know it. Look up there. Got it. When x equals negative 1 and 1. Already got those. Got it. And so, and I already have my end behavior. So I'm going to go ahead and I'm going to condense all of this onto one number line so that we can start to sketch that graph. All right. So x, I'm looking at negative 1, 0, positive 1. And I would like to know about my first derivative, which is negative all the time. And I need to know about my second derivative, which goes negative, positive, double checking my intervals, negative, positive. And then that means that I can start to sketch the shape of my curve, which let's do that in purple up here. So I have, when x is less than negative 1, I have it going down because, the slope is downward because my derivative is negative, and I have it curving downward. So it's going down and curving down. And then between negative 1 and 0 for the x values, it's going down, but it's curving up. So it's going downward, curving upward. And then over here we have it going down again, and the function is going downward and curving downward. So I have this, that nice structure. And then at the end again, a repeated idea. Ooh, what's that little tail? That's called a 3-year-old bump. That's called a painter can't draw. Yeah, you heard the 3-year-old laugh. All right, so we got all of that. All right, let's go ahead and start to make this. Well, vertical asymptotes at 1 and negative 1. And then maybe I should be sketching in purple. Yeah, I'll sketch in purple.
Purple?
Yeah, purple.
No, that's pink.
Okay, so I know I have the point 0, 0 on there. There we go. 0, 0's got to be on there. All right, so I just need to sketch my. Ooh, is that a 0 derivative value?
With you on.
It's not a 0 derivative value, so I don't want to sketch it like it is. So I know it's something like this. Notice I definitely purposely changed my curvature there, but I didn't want to put a 0 slope because we didn't have a 0 derivative. And then it's going through 0, 0. And then over here, keep in mind I said it's going to go to 0 from the negative side. So like I know this is my shape up here. I know as I go out, it's going to go to 0 because of my end behavior over here, and it's going to go to 0 from the negative side, so that makes complete sense with my shape. I was worried about that one. And then on the other side, I know that it's going to 0 from the positive side, and that makes complete sense with my shape too. And there you have it. All the right concavity, all the right slopes, one of the right values, all my asymptotes. You could check it. Hopefully it works out. I'm going to go check it, but I'll pause the recording first. So anyway, have a great weekend, and I will see you on Monday. I'm going to say goodbye.
Bye.